have so many browser windows. What's up, people? Yeah, this might be a short stream before I go to actual work. Actual work. You flew to San Francisco to party with your friends. Why are you awake at 9 in the morning if you partied with your friends last night? And you lost your wallet, okay. Work, schmurk, schmork, work, schmork. How do you pronounce that? How do you pronounce work, schmork? Yeah, I just started the stream. We haven't actually started doing anything yet. So I'll give it a couple minutes for people to show up, and then we'll start. We're just gonna improve some of the things we ran into yesterday while doing the SOA stuff. So this isn't going to be, there's going to be a bunch of little tasks. You're going dancing. Well, right on. That's good. It's getting hot in my apartment already. I gotta get the air conditioning going. EU stream will know. I mean, it may be an EU compatible time stream, but this is still coming to you from California. All right, well, let's start. Yesterday we were doing some SOA stuff, making some structs with which we could automatically make SOA versions of any data structure. We're going to do more in that direction, but while we were working on that, we ran into a few problems. So I'm just going to start attacking them, starting with the simple ones. We might not get to the more complex ones this stream, because it's probably going to be a short stream. I actually made a change for people who saw that stream. I actually made a change since then. I factored the SOA code into a different file, right? The usage code was here, right? This was just some print statements and some definitions of a couple structures, right? I've still got Steam open, man. Let's close Steam. Just some print statements and stuff, and using this SOA struct that we made. But what happened when I put it into a different file, we didn't have vector3 in scope anymore as text, and so I changed this. This used to print the type name, and it used to take 2 more lines. And I just said, hey, we could just say it's the type of the thing instead of declaring the type by string. And that seems to work fine. It also removes 2 lines of code from this. So now it's interesting. Like, this is almost all boilerplate. Like, there's this notation about this problem that we have. But really, this is like the main line that does anything in this whole function. So not sure how I feel about that, but we'll see. So the first thing that I want to do is, when we go to this added strings file, here, let's go back here for a second. Let's indent all these things that we make so that the added strings file is nicer. I mean, maybe we shouldn't need to do that or something. Maybe we should auto indent in some way, but for now, we'll do that. So if I go to this file, it's a little more readable. So these are the bodies of the functions and of the structs, and it's like, well, they don't look that much like functions because we're kind of lazy when we print them out. So I want to do a better job of printing these out, right? I want to print this out so that it looks like a function. I want to print this out so that it looks like a struct with all the parameters and stuff. Or as close as is feasible. Like, we don't have to make this into something that actually compiles. But for example, if I look at this, if I were to set a breakpoint here in a debugger, right? So this is this function set, and we say what line it's in, right? So that's helpful. It's line 62. Oh, actually, that doesn't tell us where the function is. This is the generating site. So that's down. The other file. It's down here, which is the calling site, right? So we may want to say where in the source code it is. We also may want to say what the frickin' parameters are, so that we don't have to guess what they would be by looking at the calling site, because it may not be that obvious. Do I still have the same opinion about lerp versus slurp? The same opinion as what? As when? What are you referring to? All right, so we should pick one of these. One is a function, and one is a struct. This is the struct version. This is the function version. Let's do this one. And what should we do here? Maybe we just print the type correctly instead of, so this is a type parameter, we're not printing it. This number parameter, we are. So maybe we just work on this part first, because I would like to know what type that is. Wouldn't you? I would, because without this information, if you're in the debugger here, especially now, you don't know what types any of these things are, because they're types of whatever that is. What is that? I don't know. I don't know, man. So let's do that. Why am I alt-tabbing around and around forever? All right. Now the question is, where does this frickin' happen? I don't honestly know. Added strings. How do things get into added strings? log added string. Okay. So I think it's this head extra string. I think we put these in there. Yeah. Okay. So for example, here's the I could have searched for the generated from. All right. So like when we get a body text directive, we do things. Right. So the head extra string 1 is getting this, but what about this? And wait, this is the wrong one. Because this is for a procedure. This is not the one we want. Let's look for the other generated from. Really? That's the only one. Maybe this is for both. Oh, it is for both. Yeah. Okay. So this is where this happens. So here's the struct version. So let's work on this parameter string. For everything in the constants block, you all know about the constants block. We get the declaration and identifier. And then since this is a struct constants block, instead of equal, we'll put a colon, colon. Let's do this in Emacs. Do that. And add struct parameter string. If it's a literal, we print out I feel like I should have somewhere that prints literals, but I don't know. I don't know what it would be. Print literal to builder. Why? See, I accidentally ran someone's project generator, and now I've got files that I don't. I want to just be working in the C++. I don't want to see any of this, but I am. Whatever, man. All right. Anyway. This is not what we're working on anyway. We want to work on the type. So let's just let's get rid of this having to check for a value. So if we don't have a value for some reason, I think we're going to assert false because I don't think that should happen. We're just going to return, right? So here we're just going to go switch value type case asked literal, right? Oh God, we have a nested. Add literal string literal C. We'll do this. This is fine. Hey, look, we probably should have a generalized robust routine for literal to string. Great. Okay. Add literal So there we go. Bam, bam. Emacs, what are you doing? Is that all the braces? It's all the braces. Okay. Add struct parameter string. If we don't have a value, if it's a literal, we'll keep our double question mark for cases where we get really confused. Break. All right, case. All right. And then I think I have a type to string. I think this will be easy. Don't I? Type to string. Type to string. All right. So it returns a heap allocated thing. That's got a little bit of a speed ramification. Kind of a waste, but we'll do it. Oh, we don't have our interp pointer here. That's unfortunate. C++ extract param. Do we have it here? We must. Yep. All right. Who knows? Now we get to sit through all the time of compiling C++. Okay, we got to put braces because it's a great programming language. Great programming language. Talking about the understanding Slurp and not using it blog post. Well, the mathematics hasn't changed last I checked. I don't think that the math steering committee in Math 19 has changed the behavior of linear interpolation or spherical interpolation. So I think conclusions are fine. Is that valid code? No. The stuff that we see in this file is not code at all. I mean, this is just debugging output. This never gets compiled. The stuff in here gets compiled, but this does not get compiled. And so we're just making it look more like something that gets compiled. That's all. Somebody externs add struct parameter string. Add struct parameter string. All right. Anyway, there we go. There we go. And then there we go. So now, here's our, now we know which one this is. So now it's entity, right? T is entity, N is 100. Where's the other one? Here we go. T is vector 3, N is 16. So isn't that great? Isn't that better? Maybe. So now here, what do I do there? So right now I'm just printing the structs like debug name, and when we polymorph something, we just set it to the base type dot poly. And so do I change that? Do I change the debug name, or do I not use it here and instead print something else? I don't know. How easy? I mean, I guess we can just walk. Okay, so first of all, we should put the parameters on the right side of the struct keyword, the same place where they are in the source code. All right, hold on. Okay. So we do this. Let's just do this. All right. Like, let's go. What I'm just doing is, you know, when you declare a struct, the parameters go after the struct keyword, and for some reason, I decided to put them over there when I made this debug output, which I think I was doing that because I was like, well, it's not code that compiles, so we maybe shouldn't make it look like that, but whatever. It's just a little confusing having it like that. So, okay. So now we have parameters on the right. And these still don't look exactly like what's in the code, right? Like, whoops. So here we have, you know, T is a type and N is an S64, and you fill those in. We could put this there, maybe. I'm not convinced that's worth it, because we'd have to print type instantiations, which we don't. But we might, like these are not semantically necessary once these, like this is all the information you would need, is that this is constant and it has this value. But for orienting people, it might be better to make it look even more like the source code. I don't know. But one thing at a time. We're going to get this up to a general reasonable level. Maybe this is fine now, actually. Maybe I don't mind the dot poly. Maybe I'll just think further about what the dot poly policy is. Okay. Maybe let's do this. And get it more reasonable. So we're going to want to say that this is operator brackets, because that's the syntax that you write in the language. We're going to want to get rid of the dot body. We're going to want to put the parameters here. this is weird that we have the same thing generated twice. What's that about? Maybe we have a bug where we're not deduplicating this correctly. We could tell if we actually printed out the parameters, we could tell why it thought they were different. Okay. All right, so we're going to get rid of the dot body. We're going to put the parameter string. We're going to put the return string. Okay. Let's not call this add struct parameter string. Let's just call it add parameter string, because we're going to want to call this also. And this probably won't live in polymorph anymore. In polymorph because other people want it to. And it's not really about polymorphing. Okay, so when we add a parameter string, well, let's change it down here. Add parameter string. Okay, so I want to make this code so I could use it for procedures as well. And so we're down here, and we're saying, hey, if there's a constants block, do all this. Well, I think all of this can be pulled out, well, there. So I'm going to say struct parameter string is get, what was the other one called? Add parameter string. Get parameter string for block desc constants block, right? And that's just going to be this minus the last line. All right, so right. We don't want to pass the interp too. So we're going to do that. We're going to get rid of that. Well, actually, we're going to say return that. Put that there. And bam. Okay, this is not constants block, this is just block. I mean, we could do all sorts of stuff, right? Do we have marked using? Okay, we could check this, for example. So if declaration flags and declaration is marked as using c.add using. I mean, who knows how bananas we want to get. This is for debugging output, but the less unexpected that is, the better. All right. So here we're going to say, see, we just changed this to colon, colon, but we're going to say if it's constant, we're going to add that, else we're going to add colon equals. I mean, maybe. Oh, I changed the name of this a while back, and I haven't gotten used to it. This is scope entry flags and entry final declaration. All right. Return string. Oh, I never did that. Okay. Okay. Parameter string is going to be get parameter string for block of lambda arguments block. Oh, geez. So the thing is, when we polymorph this lambda, the arguments go out of the arguments block and into the constants block, which is technically a different scope at an outer level. So like, do we want to print both of those as separate? I think so. Like, this is a weird argument. Like, you could say you want to print them all in the order that they are in the source code, right? But actually, if you polymorph some members of a lambda, then you're left with a function with fewer arguments, right? And those arguments are what you would actually call to use it. So, okay. I don't actually know if it's possible for this to be null, but we're going to check right now anyway. Okay, so we're going to say constant string is nothing. Oh, my defer is wacky here. All right, so we're just going to do this. Okay. This is going to be, return string is going to be a little bit more annoying. Because I want to tack on a thing. And like, honestly, this all would be more efficient if we passed a concatenator. Let's not worry about it. Let's just get the information and then we'll do the additional stuff. So constant string, parameter string, return string. And so if there's no return value, I just want to omit all this eventually. It's just, that's annoying. Okay, so we're using this printf style thing, which is why this is obnoxious, but we're going to switch the way it works after we get the information out. So, so we're going to do the same thing here. If returns block, I don't know if we would do pointer anyway. Okay, so in addition to saying free the strings, we want to say constants string is this for the constants block and this for the returns block. How many things did I screw up? Oh, a lot. Oh, a lot. Weird. Okay, don't use auto. Don't use auto in this fashion. Okay. Get parameter string for block, that takes interp, right? Interp. Interp. Okay, yep, like I said, one of these is not a pointer. Probably this is not a pointer either. Okay. Yep. Okay. 2355. Wait, what? Why would that be not? Did I like delete the prototype? What? Oh, I just didn't do this. That's weird. Okay. We are compiling again. This concatenator is a C++ struct. We're in C++ right now. Okay. So if we go to added strings, whoa, okay, I'm in the wrong language. I'm doing percents without the S and all kinds of things. What am I even, and of course C++ isn't telling me. I understand why you'd be confused about what language I'm in if I'm confused about what language I'm in. All right. So here, it's array subscript. S is a constant that's some type SOA. Now, we probably want to do the arguments of that polymorph struct, actually. And if we do that, if instead of printing SOA.poly, we print all the arguments, then maybe we refactor the other thing to do it. Wow, we've got so many of these. I think we're not deduplicating correctly. Like, we've got 6 of them. That's not right. We shouldn't have 6 of those. Maybe go sleep another 30 minutes. I got plenty of sleep. Okay. Now, what? So we have 2 things. Okay. We're doing dumb stuff in various places. So first of all, when I said if it's not constant, print colon equals, I wasn't thinking of the fact that if it's not constant, it may well not have a value. So we actually want to do a little bit of a different thing. And so we are going to want to print the type for those things. And then we're going to want to take care of this. Let's take care of this before the rot spreads further. So here's what we're going to do. We're going to change the way that we call this. Actually, yeah, see, even here we're calling it with a concatenator, so let's just make that the way that this works. So when we say get parameter, we're going to go right. We're going to do that. This is going to be void. It's going to be called add parameter string for block. And we're not going to return anything, right? Okay. We're going to refactor this thing on the left slightly in a minute, but first we've got to go here. And because it's C++, we have to change dots to arrows because it's a wonderful programming language. Okay, so we're going to look at this later. That is wrong. Going back over here, though, the whole reason we're doing this is this boondoggle shall not stand. So what we're going to do, we're going to move this out here. All right. We're going to say there. Colon, right? I'm taking what's in this mprintf down here and just yanking it out, right? Because we want to build a long sequence of stuff. Okay. So instead of all this nonsense, we just do this, right? And instead of this nonsense, we do this. And we skipped the parameters block somehow. I deleted too many things. No matter what, even if there's 0 parameters, we want to have parens with no arguments inside. All right. So this is much more sane and reasonable code-wise, right? And then c.add open brace new line, right? And then auto s equals c.get result defer free s. All right. As it knows the length. Okay. That's better and nicer, but of course we screwed some things up. Whoops. Okay, we don't take the address there anymore. Oh, I don't have a good syntactically nice defer. I forget. Get parameter string for block is not called that anymore. Okay. So this is in the struct version. Let's change this as well. C.add space colon space struct whatever, and then we'll do a thing, and then after that we put space open brace new line. All right, and then add parameter string for block, and actually if desc constants block and desc constants block members.items. So if it's non-empty, I mean, I don't know why we would be here if it was actually, yeah, it's not going to be empty. We could have just printed struct if it was not empty, but this whole routine is about dealing with things that have body text, which probably have parameters. All right. Okay. So we got to put this. I want to use free string, and I keep forgetting to do it. So that's the old thing. All right. So, bam. Whoops, free struct parameters. What am I doing? Oh. Okay, that has turned out better, for sure. For sure. Okay. All right, so here's our struct. That still works. Here's our procedures. We have our constants block. Maybe we'll figure out a different way to print that. This isn't something that you're able to syntactically do in the language. You can't set the constants block through program text. So who knows about that. But then this, we want to do a better job at. We don't want to put anything, we don't want to put an equals unless there's a default value, right? So, yeah, let's do one step better at a time. So here, we're going to do something more significant, so let's open this up. Okay. So we're going to say colon. I'm just going to put this for now, because we're going to have to print the type there. And we don't have a thing there yet. I'm not sure how annoying that is in the general case, because the thing that we need to print here is not the same thing as we did a thing where we print the type, but that's printing a type. Well, so there's two things. There's a type definition, which is when there's a type in the language that the compiler understands. And then there's a type instantiation, which is like your syntactic request for what the type should be, right? And I was thinking that I would have to print the type instantiation, but if we get here, we know the type definition. So let's just okay. So no. Yeah, see this type inst here? Okay, so if decal type inst, right? Else, because it might not have a type instantiation, it might be like colon equals and then a value, right? Assert decal expression and add colon equals and then so we're going to move this up to here. We're going to put the expression there, right? If it doesn't have a type inst. If it does, we'll add the inst, then we'll add a colon, right? We'll add the inst, and then it might also have an expression in that case, or it might not. And then we'll put the equal. Okay. So well, if it has a type instantiation, we had better know what it is, or we shouldn't be here, I think. So I think that. Let's see. Well, we really got some question marks out of that. The struct still works, but okay, these are more reasonable because they just have a colon in the thing, but why didn't that work? Maybe type inst value is null, and we just did an assert because we're not running the debug compiler. Now let's take 20 minutes to compile in C++. All right. Yeah, it doesn't like that. That's interesting. I would have thought that it has to be non-null. Oh. But I guess this is, okay. In order for us to have invoked a polymorph on this, the pre-polymorph thing had to have had all its types inferred. So for it, this would have had to have been set. However, oh boy. See, the thing is, so now it's not necessarily set. This becomes a very thorny issue. I think we're going to do a low effort thing here that prints the common cases. The problem is, like a type instantiation can be an arbitrary expression containing literally anything in the entire programming language. And so we'd have to have there a separate thing to print out syntax trees that like we don't have anywhere, and that would be annoying. But most of the time, your type is a few simple things. It's like an identifier or whatnot. It's just, do I even want to be in the business of printing type instantiations? Maybe. Or do I actually not want to output this string? See, there's a chicken and the egg problem. Maybe I would like to not output this string until later, when we know what the type of the thing is. But if we get a compile time error in the middle of this string that we generated, we need to be able to go look at it. So I can't wait until later to output it, because that's not that useful. So I think we're going to comment that this is why that we are doing a low effort version of the type instantiation printing. And then we're just going to do it, and we'll be mildly sad for now. Okay. So here, instead of this type inst value, we're going to say add type inst string, mildly sad about this, see comment in add type inst string. Okay, so this is going to be like add parameter string, right? So all of these, by the way, should not live in this file. And in fact, let's put that, way back on our program here where we have our list of things to fix. We'll do this. Okay, I fixed that. We're making added strings nicer, so we'll take that off that list right now. Okay, so we're doing this. Okay. I don't really want to be in the business of printing out the whole ast, but when polymorphing procedures, we need to print something useful to people to help them debug. We can't wait until the entire procedure is inferred, because it's likely that errors would happen in that infer, and people need a source code, need somewhere in source code to refer to in those cases. Well, so here we are doing a low effort version of printing a type inst that handles the most common cases. However, it is the case that a type inst could contain any expression in the language. So at some point we punt. All right, great. So what are the common cases of type inst? Well, I guess we don't have an identifier. I guess we always go type valued expression. Interesting. All right, let's do a couple of things. So this must implement name would go after, and we'll go ahead and do that. So like we'll go like if inst must implement name add or cadd slash, right, and then cadd inst must implement name. Let's go down the name chain, right? So that's for like type constraints. Okay, so we have pointer to and array element type are all good. Okay, so inst pointer to add type inst string interp inst pointer to C return can't have e.g. must implement name, because the must implement name will be associated with the inner thing, I think. Maybe not. Yeah. Right, because that would only be on a polymorphic thing, which we'll see. Let's see. So if it's array dimension, or no, array element type, then we want to print the type inst for that element type, but so if there's a dimension, we print the dimension. Otherwise, if it's this, otherwise we do this. See, look at all the junk we're doing. Right. Otherwise, if it's here, we want to add this, and then do a thing, and then add that. And the thing that we want to do is just I guess we could add parameter string. I mean, that's a little bit cheese, but interp inst array dimension C. All right, so arrays, and then if inst type valued expression here, we're just going to punt, not pump. We're just going to punt for now. I'm going to put 3 question marks so that we know that that's the new punt and not the old punt. So an identifier is the most common thing. Great. Okay, 81. All right. C++ people. Oh my God. C++, everybody. All right. Did I? Okay, I built debug, right? And I ran debug, so that's fine. Hey, look. So we got int, index int, int, etc. Value. So here we're not printing the $sign on the S. I think really this maybe goes just here. Let's think about the $sign on the S, and then let's think about what is that? Oh, it's an operator expression. That's pretty oh God. See? Now we have to start doing operator. Oh man. Man. All right. It's fine. We'll do it. Okay, so we want to do two things. We want to print the $sign. So the whole tragedy of all this is our lines of code count is just going way up as we do this. This is how it happens, people. Ident. So we have ident flags. Ident defines polymorph variable. Like that. Do I need to think about any of these other ones? All right. So there's a couple more things. Okay. Cast operator expression, else if something, else whatever. And the something is going to be, we want to do type of. That's not totally uncommon. So yeah, okay. Okay. Auto query static cast size or type of expr and add type inst string interp query C. Okay, and then if it's an operator expression, I mean, I guess we'll just do it, right? If expr, if op left, this is going to be op operator expression. All right. If op left, right. If it's a unary, it just goes on the right now. Okay. I think I have a thing to get a string from an operator token type. Okay. Token type. I don't know what it would be called. Let's look for who returns quote double equal. Print math bin op. Operator to string. Oh, geez. Got to factor a little bit more. Yay. Yay. All right. Add expression string. As expression. Okay. And then because it's C++, we get to do wonderful things. And because it's C++, we get to do wonderful things. Query, okay. So size or type of, yeah, we say, oh, right. I mean, we might as well go all the way. Okay, so if query type to query, right? Else if query kind is query is constant, right? Okay. All right, C add paren. Okay, so, and then add expression string query interp query type of expression C type of expression. So yeah, and then up here, lines of code, man. We're adding lines of code. It's not good. Here, we want to do the same thing. If query kind is query size of. Right. Query type to query. Okay, name is size of, right? Name is type of. No, type of is not. Type info. The initializer of. Add expression string. Okay, let's, we'll stay in the debug compiler for a second, even though it takes longer to run. All right, we didn't screw anything up too badly, I claim. Okay, well, this is annoying that we're printing a space here. But this is starting to be informative, right? So the thing is, we're not printing these values here. Which is still the thing that we need to know, right? Like this just says, hey, this is like that. You know, we should take the $sign off. Actually, I don't know. Because it's defined. I don't know, man. Maybe. Okay, let's take this space out. Just because the most common thing is going to be dot. Anything else? I mean, really, we did all this type of stuff, and we're not seeing any of it yet, so it's not being tested yet, but we'll test it eventually with other cases. Like these type ofs are not coming from there, right? They're coming from somewhere else. Okay. This part is the part that we need to really give the information. Stop coding and watch BlizzCon. Is BlizzCon happening? What? I mean, if they would make games that I cared about, then maybe I would watch it. I don't understand. Yeah. I mean, yeah. Heard BlizzCon got moved to Hong Kong. Yeah, I don't know. I don't know if I want to watch BlizzCon right now. I mean, you know, are you not hyped for Overwatch 2, Diablo 5, and politics? I mean, Overwatch, it's fine for people who are excited about it, but like, it's just a TF2 clone that's really spammy, as far as I'm concerned. I mean, they do a good job in the art direction and in the just the character design and stuff. Yeah. All right. So let's get some parameters here. We want to print parameters. Now, the place where this is happening, it's after the colon, so this is when we're printing a value. So this is right, so here we call add parameter string. And we get a type definition. Okay. So we are calling this code from the stuff that generates added strings, at least right now. Who knows about eventually? And that code and that use case benefits greatly from showing struct parameters. So we do that here. Okay, so if, let's go look at type definition, right? So if defin struct desc and something about that struct, like I think polymorph source struct probably, right? Yeah, so if this is polymorphed from something else, then actually, I mean, really, hold on. Let's do this a different way that's maybe mostly the same thing, but more direct to what we care about. If defin struct desc and defin struct desc constants block, and this is definitely one of those cases when I could use a continual, I don't know what to call it, operator. Constants block dot items, right? Okay. If this, then we just say add parameter string for block. And again, because it's C++, we have to frickin' do this bullcrap. Add parameter string for block, interp, defin struct desc constants block. I don't know if it's called constants block, actually. I think it might be called struct parameter block. No, it is. I renamed it. It used to be struct parameter block. Oh, yes. Okay. All right. Members items. Does the bytecode interpreter run in the same process as the compiler? Yes, it does. Could it cause issues if the bytecode accesses forbidden memory locations or modifies some state of the process? Yes, it could. Just the same as if your runtime process does that. That's not a new problem. Okay. Ooh, yeah, okay. So here, I mean, this is starting to look a little bit tangled, so I'm not sure what we do to display it better, but I mean, maybe because this is the constants block, maybe we don't use parens, but whatever. So S is SOA with T bound to vector 3, N bound to 16, right? We could get rid of the dot poly. That would help slightly. And here, I mean, the thing is, this actually just means S. So maybe we shouldn't print the $ and all that. Maybe we should just print the S. I don't know. Like, it's very important once you start doing metaprogramming to not make it look like a giant C++ mess. So we're going to want to think about that. But more important than that is actually providing the information, right? So here again, this is vector 3, 16. This is vector 3, 16. Like, these are just the same completely, right? Kind of looks like this sticks out further, but that might be an optical illusion. That's entity 100, vector 316. So our deduplication is not appearing to work, which is important to know. That means we're probably paying more for compilation than we would like. Because probably when we compile the Sokoban game, we're doing this kind of thing a bunch of times, which is not good. So that is a high priority thing. Debug deduplication in added strings. You know, because like we're polymorphing this frickin' thing like 5 times when we only have to do it once. Are we doing syntax feed text stuff? Yes, but only a limited subset of the syntax tree. I don't want to be in the business of doing the whole thing right now. And there are complications like we're not trying to print the exact source state. We're trying to print like what you should know. I'm actually just going to comment out the $ and the type restriction for now. Although, in principle, you might need it. Because it could, like, you could have a bake or something. I'm just going to comment it out and put a comment explaining what's going on. Okay. We used to do $ and type restriction in this printout, but for the purposes of being used in added strings, since we are printing a filled constants block, it is cleaner just to write the variable. The type variable without these things. Question, do we need to print these in some limited cases, like, for example, if there is a partial bake? Not sure if that's possible with body text, but we'll see. Okay, so restrict. No, here we go. We're just going to get rid of those for now. Okay, so we have this S that's a polymorph of these things. This already looks a little better to me. This double parens is like a lot, and the colons with the spaces are like a lot. But that is officially, like, these are bound to constants, so it is what it is. Let's do the last thing here. Let's put operator in front of that, right? Can I? Is that a flag on ident? Maybe we should make a flag on ident. Parse operator ident. Parse operator ident. Make ident. Okay. All right. I'm just going to do this. The problem is, the problem with this is actually a user submitted identifier. Like if you generate a syntax tree in your code, you may not set this flag, and it's not actually used for anything except debug output. But whatever. We'll cross that bridge when we come to it. Again, that would be like the whole question of like, how do we put user submitted asts into the added strings file in a way that's nice? Probably involves me printing out the whole syntax tree, like continuing the thing that I was doing, right? Because the whole thing that we're not doing much of yet, but that we're going to do a lot more of probably, is like, hey, make a function out of like just hooking up some nodes. And you want a string for that for debugging purposes, but we don't provide one right now. So yeah. Okay. So we're going to go this is currently used only for printing .added strings. Maybe we should do this a better way. Okay. So we set it there. We set it there. And then here, we do that. That's all that is. That's all that is. Let's look how long this frickin' takes. Stupid C++. Old and busted C++. Can't believe people still use this language. All right, so, whoops, I ran the wrong compiler. That's what I get for switching. There we go, much faster. Much faster. Okay, what did I just do? I was supposed to print operator and I didn't. Why didn't I print operator? Probably because I didn't hit the right place. This is a hard-coded thing, right? That's this. Oh, jeez. Oh, God. See, we don't put the ident on the lambda for some reason. We just put the atom, which is like closer to the string. So like we don't have this flag available where we want it. So I could do this a different way. So one way I could somehow preserve that flag like on the lambda. That would be garbage. Way number two, I could have the lambda use the ident instead of the atom. That might be better. There might be reasons to use the atom and not the ident that I'm not remembering. And in any case, that would be a significantly sized search and replace over the whole program and would be a little bit agonizing. And I kind of want to go eat breakfast and go to work. So we're just going to do this a different way. Why not add a adder? What are you even talking about, bro? Okay. Why not add a adder? So we're going to get rid of this thing that we just did because it's of questionable utility. We might bring it back later, but If you only keep adding things that are questionable, your program is going to suck really fast. So instead, we're just going to do a goofy hack. This is going to look worse, but it's probably not worse. We're going to say robustness. We want a better way to do this. So one of the things that I learned as I became a better programmer is that some of the things that you reflexively shy away from or think are gross are actually less gross than the mess that you make when you try to handle them in a better way that's not really much better and that's very heavyweight, right? And so let me just see if I can do like a medium thing, right? So here in the Lexer, I thought I had like a begins ident. Like, if starts identifier. Okay. We're just going to put this in the Lexer header file, right? And we're going to say that. We're just going to say, like, look, if it doesn't look like an identifier to us, put operator. Now we've got to take out this. Dude, it takes longer to build one file for Visual Studio than to build my entire Sokoban game. All right. All right, so there we go. We have operator brackets, just like in the source code. I don't actually know if that's better, but whatever. It's fine. So this is good. We can, I think we're going to end the stream here after some on-topic questions that you may have. But this has been a good improvement. So we now see, we now have more information when we go look in here. It's not cryptic. We know what the parameters are. That's great. We know that we have a problem, which is that we're not deduplicating. That's good, though, because it makes the compiler better when we fix that. So we've put that on the list of things to fix. Where could the dupes be coming from? Well, okay, so every time we array subscript, it has to notice, it has to look up the overloaded function, right? It has to notice that it's polymorphic. It has to do a type match, a full polymorph type match on it, which is not that cheap, honestly. And then after that, it then needs to decide, oh God, I know what the problem is actually. Okay, here's the thing. We are deduplicating normally for normal polymorphic things. What's happening, I bet, is that the body text directive is running before the deduplication happens because because like I said yesterday, historically it used to be the same thing as a modify directive, and modify directives all need to run before you deduplicate, because you because you need to know what the final polymorph parameters are, and the modify directives might change it, right? So the problem is we're running the body text directive, it's generating the code for the subscript every time, and then we're throwing it away afterward. So we just need to, that's my theory. We'll substantiate that theory next time. Actually, I think it is deduplicating, but running body text first. So we just need to separate body text further from modify, and that might be annoying if I mean, it's possible that some people are still doing modifies in body text or something, but it's probably cleaner to make them separate. Well, I don't see any questions, so thank you for coming by. And we will pick it up later. How many hours per day do I think I spend programming? It varies heavily, but like, why are you asking that question? If you're asking that question because you want to know if you program enough, the answer is probably not. Because if you program enough, you wouldn't have a question. Programming is hard. It takes a lot of practice. Thanks everybody for coming by. We'll continue. So I think we want to do a couple more live streams where we just work through this issue list, right? Like this, so this deduplication and this type needs to be constant in body text probably happen at the same time. Probably we'll factor this stuff out. This printing stuff we'll put somewhere else just for cosmetic reasons. Compiler bug. But yeah, we'll gradually whittle through this list, and when it's done, we'll go do more SOA features. All right, thank you everybody.